this. All right, so transformations or dilations. Now this is a specific type of transformation that produces a figure similar to the original by proportionally shrinking or stretching the figure. Now, really important that you guys keep in mind this word right here, similar. Okay? Now, take a look at the undilated pupil and the dilated pupil. And you can do this if you ever feel like it. Put yourself in a dark room, close your eyes for a minute, and before you open them, have somebody turn on the lights. Okay? A pupil is dilated. Do you see the difference between the dilated pupil and the undilated pupil? Yeah? Now, typically, if you're familiar with the eye, if the pupil gets smaller and the pupil gets bigger, which one is looking at the light? Undilated has more light, so it's kind of blocking out the sun. Okay? If the pupil is dilated and open up big, it's because there's not enough light, so it's trying to grab as much light as it can. Okay.
When we're done with those two, give them back to me, please.
Okay.
So I can finalize the grades.
All right. Now, do you see that the presentation got dilated? It was bigger, wasn't it? So I shrunk it. When you do that, the scale factor becomes a number that's between 0 and +1 when it shrinks. When the scale factor becomes a number bigger than 1, then the image gets bigger, okay? All right. Now, it has to be proportional, whether it's a larger or a smaller than the original, okay? Now, take a look at that red ball. All right. Same shape. It just got smaller, didn't it? You see the diameter of the figure shrunk too? Yeah. When we do things proportionally, the figures are still similar. It's just one of them is a miniature version of the other. Okay. Now, if we decrease the diameter, they will match the diameter of the new circle. And what happens is whatever the length was of the original circle, it should be proportional to the new picture. Okay? Now, as I blow it up, the diameter has to grow in proportion as well. Okay? Now, do you see we had a circle originally that was smaller than this? Then it got smaller, and now it got bigger. Those are dilations that we're going to work with. Okay? Now, we had a circle the whole time, didn't we? Circle. The only thing, what really was changing was when it was getting bigger or smaller. Do you guys know what was changing? The size. What makes the size of the circle change? The diameter of the circle. Yeah? The distance from one side of the circle through the center to the opposite side. What would be half of a diameter called? If you cut the diameter in half, that's called a what? The R starts with an R. Radius. When you have the radius of a circle, the radius is all the way around the same distance from the center of the circle. Okay? Now take a look at the images. Can you see which ones are not dilations? Oops. No. All right, does everybody see which ones are not dilations? Okay, A is not a dilation, and B? Yeah. Okay. The two that were dilations, the original Bart Simpson and then a miniature version, and our snowflake and our miniature snowflake. Okay. Dilations, the figures should be similar and proportional. And that's something that we're going to get to at the end of Unit 2, 3. We're in Unit 3. Okay. All right, so we're going to use scale factor and we're going to use center of dilation on the headlight. Okay, those are the two things that you got to be able to, when you leave today, you got to be able to tell me, do you understand what dilation and what the scale factor does? Do you understand what the center of dilation, what that does? Okay. All right, so we've got an image, and let's say he's 3 feet tall, and his width is about 2 feet wide. Can you see the x and y axis that we're looking at right there? Now, he wishes he were 6 feet tall. And if he was 6 feet tall, notice that his original height is 3 feet tall. To get from 3 to 6, you notice I got to multiply 3 times 2 to get to 6. Scale factor involves multiplication. So the scale factor of his width is going to be multiplied by 2 as well. So do you see, if he's 3 foot by 2 foot, if he wants to be 6 foot tall, he has to be 6 foot by 4 feet. Okay. Now, if he wishes he was larger by a scale factor of 2, that number is what we're going to multiply. So in the practice problem we just did, you guys understand that scale factor is just multiplying by the coordinates in this case. So here's his scale factor of him being 6 feet by 4 feet. Everything has to be proportional. Okay. Now, did you notice that the base didn't grow? Just the person. Yeah. Okay. All right. So his center, and this, where the center of dilation happens, is going to be something that I'm going to show you a little trick with the graphs. Okay. That's when we're going to use the highlighters. Okay. All right. So if the scale factor is larger than 1, then the figure is going to be enlarged. If the scale factor is between 1 and 0, then the figure is going to be reduced in size. It's going to become smaller. All right. So scale factor greater than 1, it gets bigger. Scale factor between 0 and 1, the figure gets smaller. Okay? All right, so are the following enlargements or reduced? So, for example, the first image is a scale factor of 1.5. So for A, was that an enlargement or was that a reduction? Enlargement. The number is bigger than 1. If it was a reduction, the number should be smaller than 1. Yeah. Do you see any ones that would be reductions? B had a scale factor of 0.75. That number is less than 1, right? So that image was actually originally a little bit bigger. Do you see any other ones? Z. Now, 1/5 is a fraction, right? Everybody have calculators on their tables? There's one right there. Pass one down. You have one on the other side. That's right. Type on your calculator 1 divided by 5. Get a decimal right. What is it? 0.2. So the scale factor of 1/5 is really a scale factor of 0.2. That number is less than 1, isn't it? So that D then is enlargement or reduction? Reduction. How about C? Enlargement. Now the figure originally was smaller, the picture. Yeah? Okay. All right, so do you guys understand A was really this size? When we multiplied it by a scale, or originally it was what we saw, but when we did the scale factor of 1/5, it got bigger. Okay. For B, the scale factor shrunk. Got it, shrunk. For C, the scale factor gets bigger. You know? And for D, the image gets smaller. Now 1/5, that's a lot. So do you understand why it got so small? Yeah. So when you guys start connecting your original points to your prime points, there should be a point where all those lines meet. That's where the dilation begins. Okay? Thank you. So original figures and your new figures, do you know, everybody all already aware of the prime symbol on the letters? The tick mark that looks like an exponent of 1. That's where our new letters are going to be labeled as we do a transformation. Okay. Make sure you label all your points on your new pictures. And you use dilations in everything. Maps, we make them smaller so we can see them, because the United States technically does not fit on this piece of paper. We're actually in one of the states of the United States and can't fit it on here. Alright. Some of the pictures, do you see any type of dilation in any of these pictures that just pops out to you? An obvious one? First one? No? Oh? Dilation, there's depth, isn't there? Going down. Look at the picture, far right corner on the bottom. Is there something in real life? Is that hamburger? Is there hamburgers that big? No. So that'd be an enlargement. Yeah. Now, when we do enlargements, we typically do that with pictures. When we make wallet size or posterize something. Yeah. What are some things you would not mind making larger or smaller? Now, you guys, I don't know if you're old enough, but cell phones, when they first came out, were pretty big. And then as time has passed by, the cell phones have gotten smaller and thinner. But now, what I noticed, like with the iPads got started getting smaller, aren't they? And the phones, aren't they getting a little bit bigger now because they're starting to become just tablets, basically? Yeah. Okay. Now we're gonna take a look at. Go ahead and pause that real quick. I want you to go ahead and go through your handout right now. And we're going to go ahead and do a dilation. Now, this is dilation of the origin. As you scroll through the handout, these are step-by-step instructions. Go ahead and scroll all the way down to the handout that says dilation A. Ready to go to that one? All right, so everybody do me a favor. I want you to write down the coordinates for A, B, and C for me on problem number 1. Just write down the coordinates. Make sure, look for the identification of where the X and the Y axis are on that picture. Are those the coordinates that you guys got? Yeah? We all got the same coordinates? Now everybody realized that the x and y axis was identified in the picture? Okay. So we're going to dilate this with a scale factor of 1/4. Now because it's a fraction, remember, when you guys are adding and subtracting fractions, you have to get a common denominator, right? Well, when we're doing dilations, we're not adding or subtracting, we are multiplying. The rules of multiplying and dividing fractions are different than when we're adding and subtracting, okay? We don't need common denominators when we're multiplying fractions, okay? So with that said, what's 1/4 times 0? 0, so coordinates of A prime are 0, comma. Now I need 7 over, I'm going to put 7 over 1, okay? Because I'm multiplying that by 1 over 4. Does everybody understand why when I write 7 over 1, that's still the same as saying 7? Whenever you're multiplying with fractions, tops multiply across, and they give you how much? Bottoms multiply across, and they give you 4. Only cross cancel if you can reduce before you multiply. If you don't do that first, then reduce the fraction if possible. Now 7 over 4 cannot be reduced anymore. The only thing that you can't do is turn it into a decimal. So go ahead and type, what's 7 divided by 4 on your calculator? 1.75, yes? What I want you to do is leave the fraction as the coordinate, 7/4. But does everybody understand that 0, 7/4 is really the same as 0, 1.75? All right. Go ahead and plot that point on the x and y axis for me. And let's see if we all get the point in the right spot. All right, make a decision where you think it goes and put a dot there. All right, did everybody place their dot 0, stay at the origin, and just go up 7/4, or 7/4 is the same as 1.75, right? Go past 1, do I get to 2? No. Somewhere a little bit less than 2, but not right, not at the middle part of between 1 and 2. And that point should be labeled what? A prime. Very good. All right, do me a favor. See if you guys can figure out the new coordinates of B prime. See if you guys can get the new coordinates of B prime. So on the last problem, does everybody agree that we didn't center our dilation in the right spot? It's centered at 0, 0. And to check where your center of dilation is, you connect your prime points to your original points that went with it. And when we did that, all of the points connected to the origin. Yeah? That's where everything opened up or shrank. So do you notice that on the first one we highlighted the x and y axis? What you just did right now is you went to the coordinate where the center's supposed to be dilated at, and you highlighted a horizontal line and a vertical line that looks like an x and y axis. That's what I want you to use as your x and y axis now. And watch what's going to happen next. The coordinates for A then are going to be 0, comma 1. The coordinates for B, what do you guys think the coordinates? The coordinates changed because we changed where the center of, where the origin was. Yeah? Because they told us, dilate this image with a scale factor of 2, but they said center it at 0, comma -1. What they're telling you is make sure everything is opening up from there or shrinking into it. Yeah? Remember on my wall picture over here, did everybody understand that when you look at this image, the lines tend to go towards the center of this picture right here? So whenever we're dilating something, we got to know where is the point that it's centered at. And if you're not sure, connect your prime images to your original images, and they'll all connect at a specific point. Okay? So now the coordinates for A, technically then now are 0, comma 1. And for B would be 1, comma 1. What would be the coordinates for C then? 1, comma -1. Now real quick, does everybody understand that we changed where the x-axis is? And do you notice the y-axis, everything just shifted down 1 unit so that the x and y-axis is now at a different place? Because the coordinates of that figure really are 0, 0 for A, 1, 0 for B, and 1, comma -2 for C, if we left the x and y-axis how it was originally. But since they told us to center it at 0, comma -1, we just went to that coordinate and drew a horizontal and a vertical line through it. I want you to do that with your highlighter on the rest of these problems so that you know where is your center of. Okay? So go ahead and find the coordinates for number 3 for me real quick. Go to -1, comma 4. So -1, comma 1, 2, 4. So on number 3, do you see that the center of dilation is at -1, comma 4 from there? That means my x-axis now is up there and my y-axis is right there. Does that make sense? Yeah? Now, use that to figure out the coordinates of that figure now. Okay? What do you guys think the coordinates for A are now?
1, 0.
1, 0, correct. How about for B?
2, 0.
2, 0, good. Now we're going pretty quickly. Is everybody okay right there? How about C?
2, 1.
2, 1. Now, you're going to multiply it by a scale factor of 3. So that means all your coordinates are going to be multiplied by 3 whenever your new coordinates are. You're going to base this as your x and your y-axis when you're graphing it. And you'll notice all the points, when you connect them, the B prime with your original B should all center at that point now. Okay? Any questions with the dilations of numbers 2 and 3? Can you go ahead and draw those two for me real quick? Numbers 2 and number 3. We already got the coordinates for number 3. I gave you the coordinates for number 2. Now you got to give me the coordinates of A prime, B prime, and C prime on the board. Okay? So everybody get the coordinates of A prime, B prime, and C prime on number 2, and the coordinates for A prime, B prime, and C prime on number 3 as well. After you get those coordinates, then we're going to plot them. Connect those points with dashed lines, not with solid lines, okay? And then we're going to check to see if your images are correct or not. Okay? And check how you guys did. All right, for number 2, the scale factor is 2. Go ahead and finish where you're at. And let's have everybody pause. All right, for number 2, what would be the coordinates of A prime? 0, 2 is correct. Does everybody understand how we get that coordinate? Yeah? All right, how about B prime? 2, 2. Everybody okay there? Yeah. All right, and C prime? 2 negative. All right, everybody okay right there? All right, let's get the coordinates for A prime for number 3. 3, 0. Scale factor is 3, so you're multiplying by 3. How about B prime? 6, 0. And C prime? 6, 3. 6, 3. Yeah? All right, so when you connect those points for number 2, 0, 2 would be right there for A prime. And then for B prime, it'd be 2, 2. 2, 2. Prime. And C prime is 2, negative 2. Right here. All right. And then for number 3, the coordinates for A prime are 3, 0. So 1, 2, 3. A prime. B prime is 6, 0. And C is 6, 3. So all right. Oh, okay, your X and Y axis in the wrong spot. That's okay, I did it too. But if you can fix it, so this is what we got to make sure when you do your center, make sure you go to the correct point and then draw your vertical and horizontal line from there. That's your new X and Y axis technically. So it does change the coordinates of those points. But do you see how you can how that changes it? Yeah. Okay. All right. Are there any questions on this part then? How we're doing this? No? All right. Your goal then is to try to get through as much of this as you can. You're going to get to cooperate with me. There's a lot of them. I know that some of you guys are, but I want to make sure that you guys, dilations is super easy. That's all we're going to work on today. Okay. When you get to this part of the handout, everybody scroll down to the handout that has the figures here. This is where we'll stop. If you get this far, stop at that page. Okay? All right. So if you finish early, I have the answer key right there on the tables right here where the folders are. When you finish one page, can you go and check your answers for that page? Huh? No, you don't have to do those pages because those are just the step-by-step instructions. Just start right here with those. So everybody see where to start and where to end today? Yeah? Okay.
I'm so confused.
Let's move back up. Give me a second here. There's dilation there, so let's go to dilation. Scale factors. Okay, so here we go. There it is, about roughly. Okay, which one are you have questions on? No?
I was just, I don't know, I kept thinking